All right, this is a different type of curriculum. So with this curriculum, you'll notice that there is a QR code at the top of all of them. That is just somebody else explaining in a different way. So if you want to hear something in a different way or you don't understand it the first time, that's always an option on the note packet. So welcome to Algebra 1. What we're going to do is we're going to look at some word problems and we're going to approach them as rates and ratios. So we're going to answer the following rate and ratio questions using multiplication and division, and then we're going to show our calculation and keep track of our units. So I know a lot of these you can do in your head, but it's good that we start writing them out to understand the process. All right, so if there are 12 eggs per carton, then how many eggs do we have in 5 cartons? So first we're going to do that there are 12 eggs over 1 carton. And we're going to multiply this by 5 cartons. What you will notice is that by having a carton here and a carton over here, that we're going to cancel out the cartons. So now it's just 5 times 12, which is 60, and eggs is the unit that is left over. So looking at the next one, let's say that we have a car is traveling at 65 miles per hour. So 65 miles in 1 hour, and we're timesing that by 2 hours. So again, we're going to cancel out the units of hours, and we're left with just miles. And 65 times 2 is 130 miles. Next one, if a pizza contains 8 slices and there are 4 people eating, how many slices are there per person? So 8 slices and 4 people. This is just going to be a division problem. So 8 over 4 is the same as 2 over 1, so 2 slices per 1 person. And if a biker travels 20 miles in 1 hour, how many minutes does it take per mile traveled? So 20 miles in 1 hour, how many minutes does it take? So we have to actually make this to where the units become minutes instead of hours. So I needed more room for that. So 20 miles in 1 hour. So we need to get rid of the hour. So I'm going to put hour up here, and we need to figure out how many minutes are in an hour. So it's going to be 60 minutes in 1 hour. So the hours cancel each other out, and 20 over 60 is what's left. 20 over 60 reduces down to 1 over 3, so that is 1 mile in 3 minutes. Rates show up everywhere in the real world, whether it's your pay per hour of work or the text you can send per month. Rates are all about multiplication and division because they ultimately are a ratio of 2 quantities, both of which are changing or varying. A runner is traveling at a constant rate of 8 meters per second. How long does it take for the runner to travel 100 meters? So we're going to experiment solving this problem by setting up a table to track how far the runner has moved after each second. So if every second they move 8 meters, that means 1 second is 8 meters, 2 seconds is going to be 16, 5 seconds will be 40, and 10 seconds will be 80. So create an equation that gives the distance d that a person has run if you know the amount of time they have been running. So the distance is going to equal 8 meters per second. Now set up and solve a simple algebraic equation based on b that gives the exact amount of time it takes for the runner to travel 100 meters. So we know the distance. The distance is 100. So 100 equals 8 meters per second. So to solve for this, we're going to divide by 8 on each side. And if I divide 100 by 8, I'm going to get a decimal. So which ends up being 12.5 equals t, and if we were to include our units, it is 12.5 seconds. All right, the previous exercise showed how we can take a pattern and extend it into the world of algebra, a world that contains symbols and conventions that may seem strange, but hopefully somewhat familiar from previous work. In the final exercise, we will tackle a larger problem to see how rates, patterns, and algebra can combine to solve a more challenging problem. So a man is walking across a 300-foot-long field at the same time his daughter is walking towards him from the opposite end. The man is walking at 9 feet per second and the daughter is moving at 6 feet per second. How many seconds will it take them to meet somewhere in the middle? So draw a diagram to help keep track of where the man and his daughter are after 1 second, 2 seconds, 3 seconds, etc. Create a table as well that helps keep track of how far each one of them has traveled as time goes on. So we're going to start by drawing a quick little diagram. So let's say that this is our road and we have one person and the other person and they're walking towards each other. The man is walking 9 feet per second and the daughter, let's make sure we know it's a girl. Yeah, look at her long hair, so cute. The girl is walking towards him 6 feet per second. What we're trying to figure out is when they are walking towards each other, at what point are they meeting in the middle? So to help us get there, we're going to fill out this table. So after 1 second, the father has gone 9 feet. After 1 second, the daughter has gone 6 feet, so a total distance of 15 feet. After 2 seconds, it's 9 times 2, so 18 feet is how far the father has gone. 6 times 2 is 12, and 18 plus 12 is 30 feet total. After 5 seconds, you're going to multiply everything by 5, so 9 times 5 is 40, and 6 times 5 is 30. If you combine them, you get 70. And finally, by 10, so 9 times 10 is 90. 6 times 10 is 60, and you combine them, and you get 150 feet total so far. So now it's saying what must be true about the distances the two have traveled when they meet somewhere in the middle. If you look at what we have so far, this 150 does not equal 300 yet, so they have not met yet. So what must be true about the distances the two have traveled when they meet somewhere in the middle? Well, what must be true is that the total distance should equal 300 feet. That is what must be true about the distances the two have traveled when they meet somewhere in the middle. So we're going to create equations similar to the last exercise we just did to predict the distance the father has traveled and the distance that the daughter has traveled. So what we know is that we need to create two different equations. So we need to find one for the father and for the daughter. So for the father, we know that the total distance will equal 9 feet times the number of seconds or the time that has been traveled. And then for the daughter, we know that her total distance will equal 6 times the time that they have spent traveling. So create and solve an equation to predict the exact amount of time it takes for the father and daughter to meet in the middle. Well, we know that the total distance has to be 300 feet. So we know that for the father's 9t plus the daughter's distance equation, 6t, if you add them, they should equal 300. So now we need to combine like terms. The like terms are 9t and 6t. If you combine those, you get 15t equals 300. As a quick review, 15 times t equals 300, so that means 15 divided by 15 is 1. So 1t equals 20, so it takes 20 seconds for them to meet in the middle.